fiber or fiber is a rope or string used as a component of composite materials, or matted into sheets to make products such as paper or felt. Fibers are often used in the manufacture of other materials. The strongest engineering materials are generally made as fibers, for example carbon fiber and ultra-high molecular weight polyethylene. Synthetic fibers can often be produced very cheaply and in large amounts compared to natural fibers, but for clothing natural fibers can give some benefits, such as comfort, over their synthetic counterparts. Textile fiber, a unit in which many complicated textile structures are built up, is said to be textile fiber. Natural fibers. Natural fibers include those produced by plants, animals, and geological processes. They are biodegradable over time. They can be classified according to their origin. Vegetable fibers are generally based on arrangements of cellulose, often with lignin. Examples include cotton, hemp, jute, flax, rami, sisal and bagasse. Plant fibers are employed in the manufacture of paper and textile, and dietary fiber is an important component of human nutrition. Wood fiber, distinguished from vegetable fiber, is from tree sources. Forms include groundwood, thermomechanical pulp and bleached or unbleached kraft or sulfate pulps. Kraft and sulfate, also called sulfite, refer to the type of pulping process used to remove the lignin bonding the original wood structure, thus freeing the fibers for use in paper and engineered wood products such as fiberboard. Animal fibers consist largely of particular proteins. Instances are silkworm silk, spider silk, sinew, catgut, wool, sea silk and hair such as cashmere wool, mohair and angora, fur such as sheepskin, rabbit, mink, fox, beaver, etc. Mineral fibers include the asbestos group. Asbestos is the only naturally occurring long mineral fiber. 6 minerals have been classified as asbestos, including trisotyl of the serpentine class and those belonging to the amphibole class: amosite, crocidolite, tremolite, anthophyllite and actinolite. Short, fiber-like minerals include wollastonite and perlygorskite. Man-made fibers. Man-made fibers or chemical fibers are fibers whose chemical composition, structure, and properties are significantly modified during the manufacturing process. Man-made fibers consist of regenerated fibers and synthetic fibers. Regenerated fibers are manufactured from natural sources, including modal, and lyocell. Cellulose regenerated fibers. Cellulose fibers are a subset of man-made fibers, regenerated from natural cellulose. The cellulose comes from various sources. Modal is made from beech trees, bamboo fiber is a cellulose fiber made from bamboo, lyocell is made from seaweed, etc. Semi-synthetic fibers. Semi-synthetic fibers are made from raw materials with naturally long-chain polymer structure and are only modified and partially degraded by chemical processes, in contrast to completely synthetic fibers such as nylon or dacron, which the chemist synthesizes from low molecular weight compounds by polymerization reactions. The first semi-synthetic fiber is rayon. Cellulose semi-synthetic fibers, some examples are, rayon, diacetate fiber, triacetate fiber. Synthetic fibers. Synthetic come entirely from synthetic materials such as petrochemicals, unlike those man-made fibers derived from such natural substances as cellulose or protein. Fiber classification in reinforced plastics falls into 2 classes: short fibers, also known as discontinuous fibers, with a general aspect ratio between 20:60, and long fibers, also known as continuous fibers, the general aspect ratio is between 200:500. Metallic fibers. Metallic fibers can be drawn from ductile metals such as copper, gold or silver and extruded or deposited from more brittle ones, such as nickel, aluminum or iron. See also stainless steel fibers. Carbon fiber. Carbon fibers are often based on oxidized and via pyrolysis carbonized polymers like PAN, but the end product is almost pure carbon. Silicon carbide fiber. Silicon carbide fibers, where the basic polymers are not hydrocarbons but polymers, where about 50% of the carbon atoms are replaced by silicon atoms, so-called polycarbosilanes. the pyrolysis yields an amorphous silicon carbide, including mostly other elements like oxygen, titanium, or aluminium, but with mechanical properties very similar to those of carbon fibers. Fiberglass, made from specific glass, and optical fiber, made from purified natural quartz, are also man-made fibers that come from natural raw materials. Silica fiber, made from sodium silicate, and basalt fiber, made from melted basalt. Mineral fibers can be particularly strong because they are formed with a low number of surface defects. Asbestos is a common one. Polymer fibers are a subset of man-made fibers, which are based on synthetic chemicals rather than arising from natural materials by a purely physical process. These fibers are made from polyamide nylon, PET or PBT polyester, phenyl formaldehyde, polyvinyl chloride fiber vinyl, polyolefins olefin fiber, acrylic polyesters. Pure polyester PAN fibers are used to make carbon fiber by roasting them in a low-oxygen environment. Traditional acrylic fiber is used more often as a synthetic replacement for wool. Carbon fibers and PF fibers are noted as two resin-based fibers that are not thermoplastic. Most others can be melted. Aromatic polyamides such as Twaron, Kevlar and Nomex thermally degrade at high temperatures and do not melt. These fibers have strong bonding between polymer chains, polyethylene, eventually with extremely long chains /HMPE. Elastomers can even be used, for example spandex. Although urethane fibers are starting to replace spandex technology, polyurethane fiber, elastolefin. Co-extruded fibers have two distinct polymers forming the fiber, usually as a core sheath or side by side. Coated fibers exist such as nickel-coated to provide static elimination, silver-coated to provide antibacterial properties, and aluminum-coated to provide RF deflection for radar chaff. Radar chaff is actually a spool of continuous glass tow that has been aluminum-coated. An aircraft-mounted high-speed cutter chops it up as it spews from a moving aircraft to confuse radar signals. Microfibers in textiles refer to sub-denier fiber. Denier and detex are two measurements of fiber yield based on weight and length. If the fiber density is known, you also have a fiber diameter, otherwise it is simpler to measure diameters in micrometers. Microfibers in technical fibers refer to ultra-fine fibers often used in filtration. Newer fiber designs include extruding fiber that splits into multiple finer fibers. Most synthetic fibers are round in cross-section, but special designs can be hollow, oval, star-shaped or trillable. The latter design provides more optically reflective properties. Synthetic textile fibers are often crimped to provide bulk in a woven, non-woven or knitted structure. Fiber surfaces can also be dull or bright. Dull surfaces reflect more light while bright tends to transmit light and make the fiber more transparent. Very short and/or irregular fibers have been called fibrils. Natural cellulose, such as cotton or bleached kraft, show smaller fibrils jutting out and away from the main fiber structure. See also, optical fiber, fiber crop, molded pulp, dietary fiber, fibers in differential geometry, ceramic matrix composite. References